Welcoming our first speaker, Jonathan Mitchener. Jonathan, the stage is yours.
Thank you very much, Sue, and good morning, everyone. I don't think the slides are moving on. Perhaps we can move on to the holding one. Brilliant. So, good morning, everyone. Thinking like a futurist. Wow. I have to thank Rory for that title, actually, from techUK, because we talked about what we could call it, and I'm really pleased because there's lots of scope with that. Right, I can go wherever I like with that. But thank you to all of the techUK team and Rory particularly for giving us the opportunity to open this morning. I think it's a great pleasure and great to see so many people who've made it through the train problems that I gather are stopping other people getting here so early. I'm Jonathan Mitchener. I'm Futurist at Innovate UK, and that's part of the Horizon Scanning and Strategy team. So I don't give out grant funding anymore. I spend my day and lots of my days with the luxury of providing thought leadership to working with businesses across UKRI and across the government, in fact. And the bit about that thought leadership is that it's about considering the types of things that could affect us in the future and be impacted in the future, and in the longer term, so medium to long term. So I'm talking mostly around multiple decades ahead. But that then leads you to what needs to happen sooner than that. And this isn't about prediction, as a lot of people think. Prediction is a bit of a mug's game, especially if you're on performance-related pay, because by the time they know if you're any good, you've retired. So it's not really about prediction. It's about giving people, like we've got here this morning, intelligent, experienced people, the space to think about and consider what the impacts of future change could be. One of the first things to note about this role is that futures is a holistic sport, right? It's not enough to think about the future of one sector or one technology area or one of anything, actually. A holistic view is absolutely important, and so many things are related and intertwined nowadays. And if they aren't currently related and intertwined, then perhaps they will be, or perhaps they could be, or perhaps they should be. So that's some of the things I'm going to think about. And so a holistic approach where we break down the silos between all of the things that we straitjacket ourselves into is really important. And rarely can one person consider all of these things from all the different perspectives. So it's a team sport as well. I remember 15 or so years ago when I was Futurist at BT, we were fortunate then to have a team of 4 of us. And that's quite a lot for a Futurist team, right? And it was a luxury. But we were all from different backgrounds, different skill sets, and it was really, really productive. It was really, really successful and worked well. There's also a very liberating aspect and element to futures thinking. It's good sometimes just to take some time to free yourself from a number of things. The first is the corporate baggage that we all carry around with us because of our role and organisation and stuff. So it's good to leave that at the door sometimes and free yourself from that. It's also good to free yourself sometimes from the challenges of the world at the moment, because in the future those challenges may well be different. And so, you know, the things you hear on the news, the things that creep into all the politically correct mission statements of companies and things like this, about greenwashing and whatnot, if you look beyond that, I think it's very, very fertile. And it's also good to free yourself from the silos, as I keep coming back to this term. Free yourself from the vertical silos that we all end up putting ourselves in, right? Because we're doing a particular job, so we narrow down and we do it better and we focus and we get more expert at it. And you tend to therefore exclude the things to the side. And those are the things that can really affect things in the future. And so to be prepared, it's good to take that time. So what's the point, right? Well, preparedness, certainly. Okay, so, and everything that brings with it. So risk reduction, identifying opportunities. and agility when things change, when the world changes. Because it will, even if you don't. Right? Even if we don't change, the world changes around us. And so it's really important. You know, the old paradox, change is constant. And the pace of technology change is speeding up. No surprise there. But from an innovation point of view, the point of futures thinking is that it encourages open minds, imagination, and collaboration. Three very important things. So let me now be open-minded, imaginative, and collaborative, in the sense of joining some of these things together that we're going to talk about today, things that are already on the agenda. I said to Rory when we discussed this lot that as well as talking about some sort of macro trends for the future, I would try to weave a story along all of the things that you're going to hear about in subsequent sessions today. And I hope that as I do that, what we'll get is it'll introduce those things, but it'll also spark some thoughts in some of your minds about things that perhaps you hadn't considered before. And if I do that, then I've probably done my job okay. So we're going to hear about digital resilience, artificial intelligence, of course, artificial general intelligence, robotics, quantum, and innovation and convergence. So let me start with those last two, innovation and convergence. We've seen how some of the biggest innovations have come from bringing two or more apparently separate disciplines or technologies together. So-called convergence, what I like to regard as perfect storms. So when technology reaches a point of its development, when combined with other things, it allows as something new to happen, a new problem to be solved, or meets a new need. So mastering single photons and the quantum behaviour, so that we can either see round corners, or so that we can do cloaking ability. That's not just useful in the military. That's got lots of applications, and we could think about that. I was really pleased recently to hear from a few colleagues of mine at Innovate who have launched a competition which brings, in conjunction with EPSRC, which brings some really early stage stuff together with some real problems. So it's called Quantum for Transport, right? Quantum solutions for transport. Really imaginative example of bringing two areas together. But it isn't just about applying innovation to new applications. I think it's also important to encourage basic technology areas to be combined more as well. So biotechnology with material science, for example, or photonics with compute. I believe that we are also still learning a huge amount about how the living world works and how that can bring new approaches and capabilities. My wife is a wonderful polymer chemist, and she's been looking at how both polar bears and sub-Saharan ants deal with temperature extremes in order to inspire new types of insulation material. And I think there's a lot more that can be done in that sort of nature-inspired technology. Of course, convergence is nothing new. Sometimes it happens almost by accident. There's lots of examples of serendipitous convergence. Consider the innovation of the horseless carriage. Right? So that came from the steam engine, the carriage, and some newfangled process of manufacturing production lines for producing these things. And actually, that's a really important point, that the process innovation is just as important sometimes as the technology innovation. So that was that. But interestingly, it came about because of a concern for the amount of horse dung that was going to pile up in the streets, not because people wanted more comfortable or faster transport. And so this illustrates how, though some issues can seem insurmountable at the time, if you project far enough into the future, it's other priorities that become important. In 2007, we saw the late Steve Jobs launch the iPhone. It brought together hardware, a bitmap touch-sensitive screen, multiple wireless technologies, more innovative form factors for the battery. It brought together with software, a slick user interface, and apps that intelligently shared data between them, and business model innovation. So what networks you could connect to, No longer was it the cellular provider that told you you had to use their network. You could connect to Wi-Fi when it suited you. And also the basis on which you paid for it. Not, I remember when we had to pay per byte. Right? You wouldn't do that nowadays. And also, eventually, what apps you could put on your phone. Right? You're in charge of that, right? Not the provider of the phone. So I think the business model innovation is really important as well, and we're going to see that particularly, I think, when AI starts to take over from search on the web, because the way we've monetized the web so far has been all through the clickbait, what you click through when you do a search and you find the list of things. Well, you won't find the list of things anymore because AI gives you the answer. So you don't visit all those sites. So the business model for actually contributing money to power the web changes. And I think that's a really important business model change that's coming. So the business model innovation alongside the tech is really important to note. And convergence is important as well. In fact, if people imagined more about how to combine some of these technologies together more, than as much as they blindly sort of apply AI to everything these days, I think we'd be in a better place with innovation. So anyway, since I've just mentioned it, let's move on to AI. When I was an undergraduate, some time ago now, AI was a bucket for everything you couldn't do yet with computers. So computer recognizing real-world objects, moving around us, and interacting naturally with us. And then gradually, as we worked out how machines could do some of this stuff, we gave them names of their own and took them out of AI a little bit. So computer vision, effective computing, and robotics. But artificial intelligence, yes, it's been an ongoing story for those of us in the computer science world for a long time, for decades. Yes, we've been through AI summers and developments and doldrums and winters. Yes, more people have used AI algorithms and systems for more time than they realise. For example, before they take a photo on their smartphone. And yes, we've been through the analytical age of AI with big data, the generative age of AI with large language models and chatbots, and now we're entering the agentic age of AI, which will bring potential solutions to higher order problems and compound questions and facilitate actions to be taken. And yes, AGI will happen. I've heard estimates from knowledgeable people on the topic ranging from 2027 to 2040. If I was a betting man and it was about prediction, I'd hedge for sort of somewhere in the early 2030s, in sort of the first half of that range. That's not a lot of time. The early 2030s is not far away. And AGI will make a huge difference. And yes, I believe that the AI revolution has the potential to do for computer processing and interaction what the internet revolution did for computer networking and access to information. And then some, by an order of magnitude at least. So what an exciting time to be involved with the tech industry in the UK and innovation. Yes, there will be bad outcomes. Bad things will happen as a result of some of this technology, like with any technology. But let's identify those and combat them. Let's promote, celebrate and embrace the good aspects, the advances, the benefits that always come from this sort of technology as well. Because we need to start restoring public trust in science, and I'll come back to that a bit later. Humans have actually shown themselves to be quite resilient to revolutions of all sorts in the past when doom and gloom scenarios were painted. We typically sort of extend and invent and rethink how we develop alongside those technologies. And I'm pretty optimistic that we'll do the same again going forwards with AI and AGI. But it does need some of the best brains to work out how society can best develop, integrate and use the technology for public good. There have always been winners from tech and the subsequent societal change that comes as a result of it, as well as those who are left behind. We should strive for more of the former, you're right, some water, We should strive for more of the former and fewer of the latter. But we shouldn't be afraid to develop the technology and to innovate because of the fears about either of them. And so to robotics. I believe that one of the stumbling blocks so far has been the single-use nature of the robot, certainly when you translate from the industrial situation to the consumer and the domestic use. I already have 4 robots at home, and each of them is designed for one specific different task. The market will take off, and it will happen when robots can be trained and used for multiple purposes. Now, there's already evidence from MIT and other studies which show that the generative AI that we've already mentioned, and which is getting a huge amount of investment and attention at the moment, can be very effectively used to train robots to do different tasks. So I have some confidence that we can move forward with this, and there's already signs that some of the big tech companies that specialize in this, and some of the ones that don't, are very interested in this space and have plans. But longer term, that generalization can have a much greater effect. As generative and agentic AI are combined with robotics, the most exciting perfect storm that I envisage is the so-called Science 5.0. This is where AI and robots do the majority of the R&D in the world. It massively scales up what can be done, and therefore the numbers and sizes of problems that we can research. AI reads the scientific papers, it designs the experiments from a prompted line of investigation, and robots are configured to do the experiments, to test, validate, and measure. The AI assimilates the results and proposes further experimentation, and reports back to the humans. And so on, until you get to some significant goal. This arrangement of R&D not only increases the amount of R&D that can be done within the world's resources. We only have so many professors and PhDs in the world, and researchers. But it crucially leads to a greater interdisciplinary approach to research, because the AI isn't siloed into looking at a subset of papers like most researchers are. You know how it is. You look at something and you look at more detail in that something. You sometimes look at something to the side, but again, it's breaking down the silo that's important. We must therefore assume, surely, that some of the greatest challenges the world faces today will be dealt with actually in a shorter space of time than we'd otherwise expect, using this sort of scientific discovery. What if we understood more about how the brain works in detail, how to correct problems with it, and how to connect it and interface machines to it? What if we understood more about the universe, our solar system, and the planet we live on, and how to reverse some of the damage we've done to it? What if we understood how to commercialize clean, abundant energy through nuclear fusion and other technologies? And what if we found preventions and cures to the world's biggest killers, and so that more people live for much longer? What happens within society in those cases? And it's very likely that the macro trends will evolve to different ones to today because of the AI R&D alongside humans, solving some of the key problems that we currently have. So what could be the new challenges that come our way? Addiction to virtual reality worlds, humans forming inappropriate relationships with machines, or vice versa, and whatever that could lead to, social incohesion, maybe people rebel against tech change or something else, conflicts in space, or pollution of the Earth's surface through dirty wars or incoming spaceborne threats, whether they're natural or otherwise. So I think science fiction actually provides us with a fertile ground of inspiration for what we might have to prioritise for next. Now, of course, we're in the year, the international year, the UNESCO International Year of Quantum. And this Friday sees the annual Quantum Showcase, not far from here actually, just up the road. I remember attending that showcase not that many years ago, and it was full of academics talking about quantum theory and early experiments. The most recent showcase I went to was full of companies, particularly SMEs, showing off early products and services. Wow, it's going to happen, and it's happening now. This technology is having and will have far more impact than just quantum computing. much of the sensing, imaging and timing aspects will change our ability to detect, see and process information securely and at phenomenal fidelity. I don't think actually the quantum non-computing parts get enough press, to be honest. When talking about the computing aspect, I always try and position it within new computing paradigms. Things like neuromorphic computing, biological computing, photonic computing. I think that in an analogy to the recent sort of trend in chip design, the emphasis for high-performance compute may well evolve to be more about prioritizing lower energy consumption alongside raw performance. And some of those other paradigms will offer great advantages in that regard. One only has to look at the performance of the human brain, how much energy we give it for evidence and inspiration. But quantum, like with AI, actually far more than AI, in the case of AI, is something where education, training and skills will be a real challenge in the next decades. For the UK to lead, even within niches in each of those technology areas, the access that it has to talent, which understands the core science involved, will be absolutely crucial. And while talking about education, by the way, it seems to me that this is an area that's really ripe for innovation and change. We've heard about personalised medicine for a long time now. But I think there's scope for personalised education, particularly when we start to use some of this AI in a very good way. So different people learn the same things, but more easily in different ways, right? Some learn it visually, some are by numbers, some by examples. And changing the way that something is explained may make the difference between somebody understanding it or not. So I think AI assistants that we're all going to be more interactive with can gradually learn how we assimilate information best, because we're talking to them all the time. And in that way, it'd be really good if they started to identify the style of education that most suits the individual that's using it. And that would allow us to personalise the education delivery per person that's used in learning processes. It's not something that's possible to scale at the moment, or even achieve in most cases of education. So as I consider my final topic from the agenda today, I think it's the first one to follow me on digital resilience. It's some of the more macro trends for the next 20 to 25 years that I will consider too. It's not only essential now to keep safe and secure from cyberspace, it will be essential to keep secure from cyber and space. Resilience from bad actor threats is easier when you can identify the actors, something that's often less and less easy nowadays. AI, from the first analytical stage, provides some really new ways to cope with the scale of threat. You only have to look at how companies like BT use AI to understand, monitor and manage network threats. But of course the same AI also provides the tools for many new types of threat. So you have to look at both sides. But still, many of the current attack vectors that are exploited nowadays rely on much more mundane effects, like social engineering, human deception and phishing. And I just can't understand why so many organisations are still using password credentials when passcodes based on biometrics are immune to some of these threats, and these vectors already exist and could be implemented today. And talking about resilience brings me on to trust. Another macro trend is a lack of public trust in governments, institutions, and even in science itself. This is a real danger. Going forward, this trust is vulnerable to even more undermining and fragmentation, and AI and these technologies can contribute to that and accelerate it through information and misinformation, for example. So over the next couple of decades, ideally starting yesterday, the importance of technology education can't be underestimated. And I actually think we need a few really great examples of UK digital solutions that work and scale for millions of citizens. That would really help. Another macro trend that I just want to mention is a kind of push-pull sort of trend. On the one hand, there's an increasing global competition in strategic areas, including some of the technology developments that we're talking about. And at the same time, there's an increased division in the global resources that are available. Digital sovereignty sounds great. Technology nationalism sounds less so. And for many people, there isn't very much difference. So world leaders have a responsibility in this, including partnering and sharing access amongst nations that have like-minded philosophies. And that can be quite difficult when some of the nations seem to change their philosophy. The final macro trend I would mention is around demographic and environmental change. People are on the move and the planet is changing. Urbanisation and where people can live could be easily influenced by the effects of the more extreme climate conditions, more often, in more places, in more parts of the world. And repeated shocks from those sort of extreme weather events will likely raise tensions between nations. Just one of the things that can happen. This will affect those relationships and partnerships that I just alluded to on the competitive and resource dividing issues. Now, I talked earlier about the internet revolution and the AI revolution. There's one more that I believe will be the next one in a couple of decades. And I can't really leave and go without mentioning it today. We may not talk about it on the rest of the agenda, but I think I can't ignore it. And that's the life sciences and biotechnology revolution. So much is already being done with synthetic and engineering biology. I remember in 2011, when I first joined what was then the Technology Strategy Board, before it became Innovate UK. And we actually had Lord Willets in post as our minister at the time. And it was great because we started a new emerging technology program then in synthetic biology. And at that time, you'd struggle to find a synthetic biologist with that on their CV across the UK. It's very different nowadays. And that's changed immeasurably. And the UK is pretty well placed in bioinformatics and biotechnology, as well as other areas of life sciences. Biotech has the potential to revolutionise and disrupt so much within the next 10 to 20 years. We already see breakthroughs, don't we, in medicine, almost monthly on the TV news, about the new conditions and diseases that we're finding therapies and treatments for. The cost of DNA sequencing is reducing. Therapies based on genetic tools, such as CRISPR, have been developed through a number of iterations now. And we've got genetic solutions for things like sickle cell. In fact, in the UK, we were first to authorise the use of that than either Europe or America. And the synthesis and engineering that we can do at the biological level will revolutionise further what can be done, not just in healthcare, but across sectors such as agriculture, food and energy. And actually, by engineering some of the food that many people eat, we could bear down on many of the health issues such as obesity. Now, of course, we do need appropriate safeguards and regulations in place, and I know people are going to talk about that later as well. But simply to put barriers in the way and slow down the UK in this area is not good. We need to protect people against biological threats as well as misdirected treatments, but we still need a fertile environment for innovation and education about these subjects. We still need to debate and inform so that people are comfortable with what is being done and where we want to draw the boundaries of safety and ethical concerns within the cultures and beliefs that we have. And so I return at the end to my full circle, to my theme of at the beginning about convergence and breaking down silos for innovation. As we progress with engineering biological systems, we need to do more to converge that science with material science, with quantum, so quantum biology, you don't hear a lot about yet, and with compute. There is such an analogy between engineering biology and engineering software, and we're good at both. So we should exploit our capabilities in bringing the two together. And it's an area I find very exciting. I've seen early stage work on producing biological compute building blocks and algorithms, especially when we can bring neuromorphic computing into the mix. Perhaps another future perfect storm. So I've taken you on a brief tour of the topics that the speakers may cover in more detail. I've tried to stretch those into the longer term for you. I've included a few extra subject areas to think about as well. I've mentioned innovation quite a bit, and strategy for the future, and you might expect that from the Innovate UK Futurist. And I've tried to do this against a backdrop of more general macro future trends. I think I'll leave it there. I hope it's provided you some stimulation for the rest of the conference and you enjoy the rest of the day. Thank you very much for listening.